Okay, let's continue with examples of linear, nonlinear differential equations. But recall that a linear differential equation, we check out the coefficients. So the linear differential equations are of this form. So of this form. And we check out the coefficients. They depend only on x, right? Okay, let me give nice examples more. So I think we are left with example number 4. So let's look at this one. So we have the seventh derivative dx to the power 7 to the power 5 plus 3 dy over dx is equal to 1 minus x. So let's look at this example. It seems that this doesn't have a problem, but you see, because of this fifth power, so in linear differential equation, the derivatives, they don't have power, right? So they don't have any power. Because of this fifth power, it is nonlinear. So because of the term 7, 5, it is nonlinear. But what about its order? What is the order of this differential equation? Is it 7 or is it 5? So what about what is the order of this ODE? Is it is it 7 or 5? So can you guess which one is it? So it is 7, right? So it is 7 because we look at the order of the highest derivative. So highest derivative, we take the seventh derivative, right? So we don't take 5, right? So it is seventh order. Great. Let's look at another example. Okay, this time we have the third derivative plus 3y square y double prime plus sine x y is equal to 1. What about this one? Is it linear or non-linear? We check out the coefficients. So this guy has a coefficient 1. This guy has coefficient sine x, but this guy has the coefficient 3y squared. We said that the coefficients depend only on x. So because of 3y squared, it is non-linear. What about the order? We check out the derivatives. We see the highest derivative is third derivative. So this is third order non-linear differential equation. Okay. Let's give another example. Let's look at this one. D square y dx square x square plus x dy over dx plus x square y is equal to cosine xy. So let's look at this one. Here we have the coefficient x square, the coefficient x, the coefficient x square. So they don't only depend on x, but if you are careful, so this should be bx, right? So this should be bx. So this should also depend only on x, but because of this y, so this is like a bxy. So it depends on x and y. So that's why it fails to be linear, right? So it is non-linear because we cannot have So it is nonlinear because of cosine xy. Because of cosine xy, right? So this is nonlinear. If we had only cosine x, then there won't be any problem. So, but what about its order? We check out the derivatives. So I see a second derivative. So this is second order. Okay, what about the y square dx square plus 5y is equal to 0? What about, okay, let me write 2. Y square is equal to 0 this time. They look very similar, right? So in the first one we have 5y. In the second one we have 5y square. So which one is linear? Which one is non-linear? Okay, I will give a hint. One of them is linear. The other one is non-linear. So if you check out the definition, we have a and x y term, right? So we can think that one as such a term, but this one is like 5y times y. So like the coefficient has y there. So that's why. So this is it is linear second order differential equation, but this one is like 5y like. So this is a2 should be a2x, but it depends on y, right? So it is non-linear, but still it is also a second order differential equation. I hope things are clear. Because of 5y square, it is nonlinear. I hope the linearity and non-linearity are clear, and I'm sorry for the background noise. So sometimes you may hear my kids noise. So sorry about that. Great. I think this is all for this week. See you next time.